Hey folks, Peter here, and today I'm going to be doing another math video, this time on a little bit of trig, and specifically this was a request I got on my Facebook post for looking at the numbers that are on the unit circle. So here I have a picture of the unit circle. This is one of my favorites. It's got a whole bunch of different blanks on it, and basically if you can fill this out, then you know the unit circle pretty well, which is, I would say, a good thing, because this is kind of an important well, it's a very important feature in trig. Normally I say don't memorize, and you're going to see that some of the stuff I'm doing here is not really memorization stuff. It relies on past geometry knowledge and some other stuff. But I think that the unit circle is eventually something you want to be able to kind of just someone could hand you this blank sheet and you could fill it out. So first of all, let's talk about the angles that we're dealing with here. So we would probably have the following angles. So we'd have 0 degrees, 30 degrees, 45 degrees, and 60 degrees in between here. And those are the three big ones. And then at the top, obviously, this is a 90-degree angle. Everything from here on out kind of repeats in weird patterns. So what you see is that so far we've done 30, 45, 60, and 90 in that first quadrant, quadrant 1. So next we're going to see, the next angle we're going to see is 120 degrees, which you can think of as a new angle, but you can also think of as okay, well, 120 is sort of like the parallel to 60 on the other side, right? It is, if 60 degrees is 60 degrees off the x-axis from in the 0 degrees direction, then 120 degrees is 60 degrees off in the 180 direction. What I mean by that is this angle here is kind of the same as this angle over there. And those are the same angles, they're the same values. It's just that the point of reference is different, right? So similar angles, different sides. And the next up we have 135, and 135 is either viewed as 45 degrees past 90 or 45 degrees less than 180. So it's kind of like the parallel to 45 degrees. You'll see why all this is important in a couple minutes. And our next angle here is going to be, almost forgot it, 150 degrees. So as you can probably tell, I don't see that one as much. And then of course we have 180. Down on the bottom, we have some more. So this is going to be 210 down here. That's 30 degrees past 180. We have 225. That's 45 degrees past 180. We have, oh boy, we have 240. We have 270. I haven't done this in a while. And then we have 300. And over here, 330. And the one in between is 315. And if you're wondering why I wrote them in that order, I did forget the 45-degree angle in the last quadrant. So those are all my angles. Those are the ones I'm interested in. These are the ones you'll basically always be labeling or thinking about when it comes to unit circle math. Now, obviously, there are other angles in a circle, right? Also, there's, I guess, 360, which is really the same as 0. There's other angles in a circle. I could say, 217 degrees, and that would be in there somewhere. But with the unit circle, we really only look at these core, I would say 5 angles, but it's also what is that, 12, 16, 17 key angles, but really it's just 5. So let's start out with, well, before we do anything else, we need to understand what the unit circle is. So the unit circle is a circle of radius 1. Radius 1 meaning that the distance from the center in here to the outside at any one of any of these different points on the circle, it's always 1. Okay, I'm going to get rid of the blue because that's ugly. So that tells us something about some of these angles. But to understand why, we need to draw 2 reference triangles. The first one I'm going to maybe I'll draw 3. It'll just make this easier. So the first one I'm going to draw is like this. Okay? Now to understand this next part, you do need to know something about 30, 60, 90 triangles. So this here is a 30, 60, 90 right triangle. This is a special kind of right triangle. The 30, 60, 90 right triangle has relationships between its sides that you might have learned in geometry. Basically, it goes like this. If this side over here is x, then the longer leg will be x root 3, and the hypotenuse will be 2x. Okay? So if the shortest leg is x, then the longer leg will be x root 3, and the longest leg, well, not leg, but the longest side, the hypotenuse, is going to be 2 times the shortest side. Now, looking at the unit circle again, and I'm going to try to sketch this in as best I can, what we see is that there is this exact triangle happening over here. Okay, so I'm going to draw this in blue, and then I'll probably get rid of it. So what we see is a 30-degree angle in here, 60-degree angle up here by definition, because we've dropped that angle, it becomes a right angle. So when we draw in that right triangle, it is a 30, 60, 90, right? So what we're going to do now is take that over to the triangle we have drawn. We're going to try to figure out what's going on with how that helps us understand some of these different numbers. Okay. So, if we go back to the triangle on the left, what we know is that this hypotenuse, which we just drew in over there, is a radius of the circle. And any radius of the unit circle, like we were talking about earlier, it's the unit circle. So the radius is always 1. So what we're going to say is that this 2x equals 1. Okay? That's really important. Knowing that the hypotenuse of that triangle is 1 is really important, because that tells you that the shorter side, the height of the triangle, is half of that, or 1/2. And then this other one is, well, you got to take the 1/2 and multiply by root 3, so that's going to give you root 3 over 2. Okay, so what you see now is we have this triangle. It's got a hypotenuse of 1. Because it's a 30, 60, 90 triangle, that means the short leg is 1/2, half of that, and the long leg is x root 3. Now if we go back to the unit circle, what we can now do is label the points, the point here at 30 degrees, because we know that this height is 1/2. So the y coordinate is going to be 1/2. And we know that when we draw that height in, this length over here is root 3 over 2. Okay? So that has actually given us our first point on the unit circle. Root 3 over 2 is the x-coordinate. 1 over 2 is the y-coordinate. Now, if you are looking at these and saying, okay, well, why do I care about that? Here's what gets interesting. On the unit circle, x values are cosine values, y values are sine values. So what this point's coordinates are telling you is that the sine of 30 degrees is 1/2, and the cosine of 30 degrees is root 3 over 2. So knowing the coordinates of the point are really important, because once you know the coordinates of the point, you know the cosine value and the sine value attached to that angle. So, unfortunately, the next triangle we have to look at is a different kind of triangle. It's a 45, 45, 90. And the reason I know that is because, again, if I draw a right triangle here, remember this is the 45 degree line. If I draw this right triangle, well, it's got an angle of 45 degrees down here. And I'm drawing in this again to get the height drawn. And there's my triangle, right? So this is a right angle, or at least it should be. And up here, that means this up here has to be 45 degrees. Okay, so this is another kind of special right triangle. This is a 45, 45, 90. Okay, I'm going to get rid of all those drawings. Okay, and back over here on the left, I'm going to sketch this triangle for you. Okay, so here it is in our kind of more controlled environment. You'll notice this one is what's called an isosceles triangle, right? These legs should be the same if I drew it better. And it's got a right angle there, and this angle is 45. and this angle is 45. Okay, so let's talk about what we know about this kind of triangle. Well, in this kind of triangle, the side is x. This side is also x because it's isosceles. That's what isosceles means. The two angles are the same, so the two legs are the same. And we have this other side. Now, if you apply the Pythagorean theorem to this, you add the x squared and the x squared, and you get 2x squared. You take the square root of that. You're like, oh, okay, I got x root 2. So this last side is x root 2. So if you know one of the legs, then the hypotenuse is just root 2 of that. Unfortunately, we don't know the legs. We do know the hypotenuse. So what this tells us is that the x root 2 is 1. Remember earlier we said unit circle, the radius or the hypotenuse of these triangles is always 1. And that means that, yep, this one's going to also have a hypotenuse of 1. The reason this is kind of a pain in the butt is you got to divide by root 2 to get x, which are the leg lengths. But if you do this, what you can do is take 1, divide by root 2. Math says square roots on the bottom of fractions are bad. Okay, I don't have time to explain that right now. But if we multiply by root 2 over root 2, that'll get rid of the fraction, or the square root on the bottom of the fraction, because it gives us 2 on the bottom and root 2 on the top. Okay, so all things considered, x is root 2 over 2. And fortunately, now that we've done that math, we've also found the bottom leg as well, which means the coordinates of this guy, the 45-degree angle, are actually pretty easy to label because it's the same x and y, meaning root 2 over 2, root 2 over 2. Okay, so there's our sine and cosine of 45 degrees, and I'm just going to make sure that point is clear over here. So again, this tells us that the cosine of 45 degrees is root 2 over 2. And the sine of 45 degrees is the same. It's also root 2 over 2. So now you have cosine and sine values for 45 degrees. Okay, let's look at this last angle up here. Okay, this is 60 degrees. Now, if we sketch in the triangle, and this is kind of interesting, we actually get a triangle that we've seen before. But I'm going to redraw it just so you get the chance for that. So, okay, here's my line. There's my hypotenuse that has length 1. And then I drop my perpendicular, draw the short leg. There you go. Okay, so this is, if we have 60 degrees down here, 30 degrees up there. Oh wait, we've seen this one before. This is the 30, 60, 90 triangle that we dealt with earlier. So I'm going to sketch this in. Let me just get rid of it over here. Okay, and I'm going to sketch this in on the other side so we can kind of pick it apart and see what's going on with it. Now we already did this one, so I'm going to kind of give you the skimmed version with a triangle that's drawn really, really poorly. And basically we have, again, if x is the shortest side, then, okay, x root 3, not a great root, is the longer side, and 2x is the longest. So, again, 2x equals 1 because the hypotenuse of every triangle on this unit circle is always 1. That means that x is going to be 1/2, and x root 3 is going to be root 3 times 1/2, or root 3 over 2. Okay, so now we look at the triangle, and we see, okay, this time the x-coordinate, right, the length across the bottom is 1/2, and the height of the point is root 3 over 2. So we can label those. Let me try to, oops, that was a red bit that I didn't want. All right, let me zoom in. And, okay, so we just said that the x is 1/2, and the y is root 3 over 2. Now this is kind of interesting because if you compare that to the sine and cosine of 30, they're the same values, they're just flipped. Right? So you see that the sine of 30 degrees is 1/2, and the cosine of 60 degrees is also 1/2. So That's kind of interesting, and it will actually help us as we keep going through these to recognize that pattern. So now we get to the top. Now the top of this is really easy because it's 90 degrees straight up, and you remember that the radius of the circle is always 1. So straight up means we did not move on the x, so cosine is 0, and we did move on the y. All our movement was in the y, so we are 1 unit up. This also helps us understand what's going on over here at 0 degrees because we did not move up at all. We moved only to the right. So we went 1, 0. Okay, and I'm going to say, now that we have all of those, we can kind of stop doing the math stuff because what happens as we keep going through this triangle is these numbers repeat over and over and over. The only difference is the sign, meaning positive or negative. Okay? So what I'm going to do before we go into this next part is, there's another reason I like this circle. It gives you, right at the top here, I'm going to circle it, positive and negative. And you can just write these in at the beginning when you're going through these. So in the first quadrant, x and y are both positive, which means cosine and sine are both positive. So we can think of this as like, okay, x and y, and cosine and sine. None. There are no negative quantities in that first quadrant. Now, if I look at the second quadrant, okay, now I've gone left of the y-axis. That's probably backwards for you guys, right? So now I've gone left of the y-axis. I think that's the right way. And so now my x values, or my cosine values, are going to start being negative. So I can say x, oops, that's not the pen, x or cosine over here is negative, and y, or sine, is still positive. So here's what's cool. If you look at 60 degrees, we're at 1/2 in the x, root 3 over 2 in the y. Now if we look at 120 degrees, which is 60 degrees in the other direction, well, no. Yeah, it's 60 degrees up from 180 instead of 60 degrees up from 0. We'll think about it that way. We're moving over 1/2, except now it's over 1/2 in the negative direction for the x, and still up root 3 over 2. So I'm going to write the 1/2 in red, so that's easy to track. And we'll make sure to label that as negative as well. So that is negative. Oh, I'm actually, oops, don't mean to be streaming right now. So that is actually negative. And then I have the y value, the sine value, and that is still positive like it was over in 60 degrees. Because we're still above the x-axis. We're in positive y values. Okay, now if we continue this trend, what we see is that the 45 degrees flips over the same way, right? Where we're going to have now a negative x value, so negative root 2 over 2, positive root 2 over 2 y value. Okay, and the same thing applies to 150. If you look at 30 degrees, well, we're now at that same point, but across the axis. So now our x value is negative, negative root 3 over 2, positive 1 over 2. And of course, this brings us out to the point at 180 degrees, where x is negative 1 and y is 0. All right, so let's keep up this trend. We're going to keep going around. We're going to start by labeling the quadrant 3 as positive and negative. While down here, everything is negative. Meaning, x, y, sine, and cosine, those are all negative. I mean, if x and y are negative, then obviously sine and cosine are negative. So what we do is we start mapping these things over. If you look at 210, what we're looking at is 150 up above, coming down. So now it is still true that the x is negative root 3 over 2, but now we also have the y is also below the x-axis, So that's negative 1 over 2 as well. If you look at the next one, both of these are going to be negative, so negative root 2 over 2, negative root 2 over 2. And for this last point down here, we get negative 1 over 2, negative root 3 over 2. And you notice all these numbers are the same, but the signs are changing as we go through. But you see kind of the same x value, same absolute value of the x coordinate and the y coordinate all the way through these things. It's just the signs that are changing. If you look at the bottom of the circle, of course we have 0 in the x because we have not moved off that y-axis. Negative 1 in the y. And now we get to the fourth quadrant. Now down here, what you're going to see is that we have basically the same thing going on, but we want to start by labeling, okay, what's positive, what's negative? Well, we're still below the x-axis. We're underground, so all the y values are going to be negative. And that means that sign values are going to be negative. X values, though, are going to be positive because we're to the right, there we go, got it right, of the y-axis, which means our x values are going to be positive. So what we're going to see here is that you can look to a bunch of different places to get some help with this, but you'll have the same points, right? So our first one should be 1/2 root 3 over 2. If I'm looking over at, so what I'm kind of doing for this, by the way, is I'm looking over here. I'm saying like, okay, that point is my reference. So 240 was 1/2 in the x, which is now positive. Let me get rid of that. 1/2 in the x, so that's positive. And then for the y, that's still negative. So negative root 3 over 2. Okay? Looking at the next one, well, this is the one where it's always, it's 315. It's one of the 45s. So it's always root 2 over 2, root 2 over 2. In this case, positive root 2 over 2 for the x, negative root 2 over 2 for the y. Finally, we got 330 degrees. Well, this one is, if I'm looking, actually I can look up at 30 degrees here and say that x is going to be the same because they're both root 3 over 2 to the right of the y-axis. And then the y is going to be, a little different, negative 1 over 2 for the y. And this gives you every point that you might encounter on the unit circle, all the way around using triangles as a justification, and then using patterns to get the rest. Okay? I want to show you one alternate approach to this, and this is where I would say counts as a little bit of a trick. Okay, so one thing you can do here, and again, this is a trick. It's not necessarily like the best way to do this. If you really want to understand this stuff, understand what I did on the first slide. But if you want to see the trick, I'm going to show you because I think it's a good one to know. So what you do here is everything follows this pattern. Basically root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. The reason I like this trick is that it's easy to remember. Now, each of these values gives something interesting, right? So if we do root 0 over 2, well, root 0 is just 0. And 0 over 2 is just 0. So that gives 0. Root 1 over 2 is 1/2. Root 2 over 2, I can't actually simplify that. So that stays. Root 3 over 2, again, can't simplify that. Root 4 over 2, well, root 4 is 2. 2 over 2 is 1. So these are going to have some red values associated with them, but I just want to show you the pattern. So here's what we're going to see. In the x direction, if we start down here, we see root 0, nope, just kidding, root 4 over 2. See, this is why you should never use tricks, because you have to memorize them, and if you remember it wrong, then you get the whole thing wrong. I remembered it wrong because I remembered it starting at 0 in the x, and it doesn't. But we start at root 4 over 2. Next, we go up, so we drop down by 1. So now this is root 3 over 2. And if you go up again, it's root 2 over 2. And if you go up again, it's root 1 over 2, which is actually 1/2. And then if we go up again, it's root 0 over 2, which we saw was just 0. Okay. The cool thing about this is if you keep going, it keeps working. So over here is negative root 1 over 2, which was just 1/2, negative 1/2. Over here is negative root 2 over 2, then negative root 3 over 2, and finally negative root 4 over 2, which we saw earlier was 1. Now what's cool is if you look at these trig values and you actually do all the conversions out and you check them compared to the x values we got in the first unit circle, they do match. Okay, and I can't really show you them both at once, but they do match, right, if you actually do them all out. So this trick does give you the right values. So I'm going to keep going with it. We're at negative root 4 over 2, so the next place we go is negative root 3 over 2, negative root 2 over 2, negative root 1 over 2, and again that's half, and then finally root 0 over 2, which is then going to come back around, so we got root 1 over 2, root 2 over 2, root 3 over 2. And again, this is just a good way, if you're looking for some extra help memorizing it, this is a good trick to know so that you can kind of catch that pattern. It's especially useful for like if you're taking a test, it might be a help. So now let's look at the y values. Okay, so here we do start at root 0 over 2. And we move up, right? So root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, and remember that's just 1. Then we move down again, so root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. And we keep going. Now we're negative, so we keep going down, root 1 over 2, negative root 2 over 2, negative root 3 over 2, still negative, negative root 4 over 2, so that's actually negative 1 now. We're dropped all the way down. Over here we're at negative root 3 over 2, negative root 2 over 2, and finally negative root 1 over 2. So this is a nice way to remember. It's kind of easy because you can track that pattern all the way around the circle. Sorry for some of the writing on here. I know I didn't hit all the lines exactly right, but hopefully this helps you as a neat memory trick in addition to the understanding you now have maybe of the triangles and how they work. I will see you guys next time. Probably have a Wired Wednesdays for you tomorrow, but I hope this helped with your unit circle knowledge.